This video is for the second half of the rational functions section. So the rational functions section has you graph rational functions first, and then the second half is a review of all the functions you should know how to graph up to this point. So it's kind of a review, but it's a lot of information to review. So they start with linear functions. A linear function has the equation y equals mx plus b. The graph will be a straight line. It has something called the parent function. That's the most basic line you can have, f of x equals x, or sometimes they write it as y equals x. It can be written both ways. And that basic line is a line directly in the middle of the graph. It's that 45-degree line, and it would go exactly up 1 unit over 1 unit. So it goes through the center, and you go up 1 over 1, up 1 over 1. So it's crossing at 1, 1, 2, 2, 3, 3, 4, 4, or negative 1, negative 1, negative 2, negative 2. On the equation, m would represent the slope of your line, and b represents the y-intercept. So that's why we start in the middle. There was no b behind here, so b was 0, which means we start in the middle. The slope is the number in front of x, and in front of x is a 1. So if there's anything ever behind x, it's a 0. In front of x is 1. So our slope on this one would have been 1 over 1, so that's why we go up 1 over 1, up 1 over 1. We also know something is linear when the highest exponent on the x is a 1. We don't have any higher exponents. The second function they review is a quadratic function. So a quadratic function looks like this in standard form. Y equals ax squared plus bx plus c. And its most basic one will be a parabola. Again, we start at the origin, and it's specifically going through the points 1, 1 and 2, 4. Or negative 1, 1, negative 2, 4. So the parent function, the equation for this most basic graph, is f of x equals x squared. Again, that could be written as y equals x squared. And when you look at a quadratic function, it has something called the axis of symmetry. It's a line that cuts that parabola exactly in half. You always find that using the formula x equals negative b over 2a. So this is the axis of symmetry. So for example, if you had y equals 2x squared minus 4b plus 3. Sorry, that should say 4x. I was thinking of the fact that it's bx minus 4x plus 3. So b is the number in front of x in the middle there, and a is the number in front of x squared. So plugging that into the formula, we have negative from the formula. B itself is negative 4 over 2 from the formula times a, which is 2. So negative outside of negative is positive 4. 2 times 2 is 4. And 4 divided by 4 is 1. So x equals 1 would be the axis of symmetry for this particular quadratic. And on our quadratic, the greatest exponent is 2. That's how we know it's a quadratic function. The next kind of function was an absolute value function. That looks like this, y equals x minus b plus c. And you may use different letters here, b and c, they could be written differently. And it doesn't matter so much what letters are there specifically. We've seen it as h and k or a and b. Depends on which textbook. So the absolute value graph is a V shape. And it's similar to that parent function of a line is where we're going up 1 over 1, up 1 over 1. But then we're going up 1, left 1 on this left side. So the parent function would be f of x equals absolute value of x. That's the most basic function. And then when we go to find our other functions, it's determined off that b and c. How you graph your absolute value is you start with that parent function, and then you take this and move it around. You can shift it up, or you can shift it down. You can shift it to the right or to the left. You could go right, then down. And the way we know how far we're shifting around is by that b and that c. So if b is a positive number, then we go to the left. If b is a negative number, we shift right. Those are opposite of what we expect. If c is positive, we shift up. And if c is negative, we shift down. So let's say you have y equals absolute value of x plus 2 minus 1. 2 is in the b spot, and 2 is positive, so that means we shift left. Negative 1 is in the c spot. It's negative, so we shift down. So I can actually move this and go left 2, down 1. If you couldn't actually move your graph, then you just count from that vertex point and go left 2, down 1. So that coordinate on the pointy part of the V, that is the vertex. So the vertex for this graph would be negative 2, negative 1. The next graph is exponential. Exponential graphs are y equals a times b to the x. If you have exponential growth, it would go in this direction. And if you have exponential decay, it would be going down. We'll talk about how to know which one is which in a second. So this exponential function, we know it's exponential because the variable is the exponent itself. So we will know if this is growth or if it's decay by the number here for b. So the number attached to the variable x. If b is bigger than 1, we have exponential growth. If b is between 0 and 1, we have decay. So an example of growth would be y equals negative 3 times 2 to the x. Didn't need a parenthesis there. An example of decay would be y equals 5 times 2/3 to the x. Since it's a fraction, I do need a parenthesis there. So b was bigger than 1 here, and b was between 0 and 1 here, which tells us when we have growth and when we have decay. So the last function to review is the square root function. Which looks like this, y equals square root of x minus b plus c. And this one looks different than absolute value, but it acts the same way. We're going to have that horizontal and vertical shift going on again. But it starts out looking differently. So we start our graph here in the center. The next point is 1, 1, and then the next point is 4, 2. This one only goes one direction. It probably should be a little more curved. So that is the parent function. Y equals square root x would be the parent function. And the horizontal and vertical shifts acts the same way. If this number b is positive, we go to the left. If this number b is negative, we go to the right. If c is positive, we go up. If c is negative, we go down. So positive goes left, negative goes right. For this, positive goes up, negative goes down. So for example, if we had y equals square root of x plus 1 minus 3. Again, I can actually physically shift my graph, or at least a part of it. Let's see if I can shift this. Yep, so I could pick this whole thing up and go, let's see, positive 1 would be left 1, negative 3 would be down 3. So I'd shift left 1, down 3. But if you don't have the ability to do that, you would just go through each point and do the shift. We have left 1, down 1, 2, 3. Left 1, down 1, 2, 3. Left 1, down 1, 2, 3. And there's our new square root function. So then it also reviews rational functions, but we talked about how to graph those in the first video for this section. And you can always check your graphs by using that website, by using desmos.com. It's a great online graphing calculator, or if you have your own graphing calculator, that can be a big help when you're doing so many graphing problems. So that concludes our discussion on rational functions.